Good afternoon. This is your live lesson from September 9th, Wednesday. We are covering equivalent fractions today. So let's start with our number of the day, which is 11. And the factors for 11 are 1 and 11, because the numbers you multiply together to get the number are the factors. So 1 and 11 are the only factors. And that makes 11 with two factors, making it a prime number. So make sure you go ahead and add that to your list of numbers. And if you remember, we covered this yesterday when we made our calendar. So what are equivalent fractions? So an equivalent fraction, if you paid attention during the pre-class video, is a fraction that is equal to another fraction. So for example, 1/2 is equal to 3/6. 1/2 is equal to 4/8. And if I draw my model, here's my 1/2. And then essentially what we're doing is we're cutting this into 3 equal pieces. But when we cut up our fraction, we have to cut up the entire whole. So now I have 3 out of 6. And here I would cut this into 4 equal pieces. And again, I'm not just cutting up the fractional part or the shaded part. You cut up the whole, and that's where you get your 4 out of 8. So how do we show this mathematically? So 1/2 times some number equals 3/6. So if you remember when you first learned to multiply, we would say 1 times 3 equals 3. 4 times 1 equals 4. 27 times 1 equals 27. 9,672 times 1 equals 9,672. So any number times 1 equals that number. So when we multiply fractions, we're multiplying by 1. That 1 just looks different. In fractions, if I said, what is 3/3, you would tell me that equals 1. And that's exactly what we're going to do. So what times 1 would give me 3, and what times 2 gives me 6? Well, that would be 3/3. And you can see we didn't change our fractional part at all. All we did was cut it up into smaller pieces. So when your numbers get larger in fraction, your pieces get smaller. And you can see we still have the 1/2 there. Now it's either in thirds, 3 and 6, or eighths. We cut it into 3 pieces or into 4 pieces. So 1/2 times, and if I think of this as my 1, 4/4 gives me 4/8. Okay, so let's look over here. We have 1/3. So here's my 1/3. And I want to find equivalent fractions for 1/3. So I see that my first equivalent fraction is 2/something. So if I were to cut this 1/3 into half, how many pieces do I now have? I have 6 total, and 2 are shaded. So 1/3 times 2/2, and that's my 1 equals 2/6. My next clue tells me that 9 is my denominator. So 1/3 times something equals something over 9. Well, what times 3 would give you 9? 3. It's a bad 3, I apologize. 3 times 1 is 3. 3 times 3 is 9. So if I cut this into 3 pieces, you can see where I get my 9 total pieces of the fraction, and 3 are shaded. So this number would be 3. So here I have 4, and we're going back to this original fraction of 1/3. What times 1 gives me 4? 4. So 1/3 times 4. If I multiply the numerator by 4, I must multiply the denominator by 4. That's going to give me 4/12. And if I add another line here, cutting my original third into 4 sections, then I can see where my 12 comes from. And last, we have something 15. Well, what times 3 gives me 15? 5. 5/15. So when we're multiplying to find equivalent fractions, okay, so to find equivalent fractions, and you should be taking, sorry about that, equivalent fractions, and you should be writing this in your notes. You multiply the numerator and denominator by the same number. So if I said, we can look at 1/3 times 2/2, and that 2/2, 3/3, 4/4, whatever the number is, equals 1 whole. So we're multiplying it by 1. We're not changing the original fraction in the sense of the amount of it. We're just changing how it looks. So that gives us 2/6. Okay, if you need to pause the video, go ahead and do so that you can take your notes. I will continue on. Okay, so let's look at these examples here. And I'm going to show you another way that we can make equivalent fractions that might help you understand a little bit better. So there's a way that's called, to some people, a lazy T. And T just stands for table. And the reason they call it a lazy T is because it looks like it's laying on its side. So I'm going to write out here my 3/5. And remember how we talked about multiples and factors? Factors, that's what we've been doing to find our prime and composite, listing the factors of a number, what two numbers we multiply together. Our multiples, it's like skip counting. So when you list the groupings, when you count by a certain number, so like 3, 6, 9, 12. So that's what we're going to do. We're going to list our multiples for each of these. I like to start with the denominator and list my multiples for my denominator, then my numerator. You're not going back and forth and you don't get confused at what you're counting by. Now, in our last examples, we started with a 1 as a unit fraction, 1/3, 1/2. So now we're going to look at some fractions that aren't just unit fractions. So if I count by 5s, it would be 10, 15, 20, 25. I'm just going to stop at 25. Now if I count by 3s, for my numerator, it would be 6, 9, 12, 15. These are my multiples for 3, my multiples for 5. All of these equal equivalent fractions for 3/5. So if I have 3/5 and I multiply by 2 over 2, that's my 1/2, I'm going to get 6/10. If I have that same 3/5 and I multiply it by 3/3, I'm going to get 9/15. So what we're doing when we list our multiples is saying this is times 2, this is times 3, times 4, times 5. Same thing across the bottom. It's times 2, times 3, times 4, times 5. This is kind of like when we do long division, we list out our multiples so that we can get an idea of what's close when we're multiplying. So we're not just doing blind guess and checking. So they're asking for equivalent fractions for 3/5. Well, we can say 6/10. We can say 9/15, and I don't have to go in order. I could go all the way to 15/25. So for 3/6, let's make a table. And if you're not good with your multiplication facts, this is really helpful. And as we start adding fractions, you'll see how it becomes more helpful. Okay, so if I count by sixes, it would be 12, 18, 24, and 30. We could go to 36 if you'd like. Now I'm going to count by threes. 3, 6, 9, 12, 15, and 18. All of these fractions, 6/12, 9/18, 12/24, 15/30, 18/36, those are all equivalent fractions to 3/6. So go ahead and write this in your notebook. If you're not, make sure you have your notes. And let's take a look at our last slide. Okay, so our last slide, again, we're just finding equivalent fractions. And 1/4 is the first one. And then we have to find the missing parts on the second one. So if I list 1/4, we could do 2 times 2 over 2 gives us 2/8. 1/4 times 3 over 3 gives us 3/12. So when we're looking at this example here, we're always going back to the 2/3. It's not to the 4, whatever this equals. We always go back to the original fraction. So if you want to do it by the table method, they want to know the first 4. 1, 2, 3, and 4. So we already have 2/8, so 4/8, 12, 1, 2, 3. When there's a 1 on the top, you just simply go 1, 2, 3, 4, and 5. And then here we have 4, 8, 12, 16, 20. Okay, those are your first equivalent fractions for 1/4. Now, 2/3. What times, I'm going to go ahead and write over here, 2/3. We could do the table still. 3, 6, 9, 12, 2, 4, 6, 8. Because what we're saying is 2/3 times something equals 4 something. What times 2 gives me 4? 2. Well, if I multiply the numerator by 2, I multiply the denominator by 2, and that gives me 4/6. We see 4/6 in our table. Okay, we have 9, so I could say 2/3. Let me separate that. times something gives me something over 9. Well, what times 3 gives me 9? 3. So if I multiply the denominator by 3, I must multiply the numerator by 3. That gives me 6/9. This just happens to work out where they're both 6. It's not some magic that it's going to be 6 here and then 6 there. It's just the way that the numbers worked out. If I had 1/3 instead of 2/3, my numerator would be different. It would be 3/9. All right, make sure you take your notes. Your assignment is in Schoology and work in iReady for at least 20 minutes. I'll see you in class.